Hello everyone, and welcome to part 2 of the Python crash course. Let's go ahead and jump to a Jupyter Notebook to get started. Alright, here I am at a Jupyter Notebook. Last time we left off on how to grab items from a nested list. We went over strings and lists, and those were related to each other because they're actually just sequences of elements, and you can use the same index notation whether on a string or on a list. You just pass in brackets the actual indices you want and grab the elements that are at that index or slice of the index. Let's go ahead and switch gears to thinking about dictionaries. You can create a dictionary in Python by specifying curly brackets, and then you'll have a key, a colon, and the value that corresponds with that key. To show you another example, we'll go ahead and make key2, colon, and the value for key2 will be 1, 2, 3. Dictionaries behave as key-value pairs, just like a hash table. And instead of holding elements in a sequence, they hold elements through keys and then their actual values. So instead of saying something like D0, that's not going to work because there is no key there, and it doesn't hold it in an actual sequence position. What you end up passing in the bracket notation is the actual key itself, and it will return the value. So for instance, if you wanted to get the number 123 here, you would call your dictionary and then pass in the key corresponding to that value. In this case, 123. And dictionaries can take in basically any items as their values. So we can have a key, K1, colon, and then you can actually have another list in here, 1, 2, 3. And now if I call dictionary, I have one key, K1, and then the list, 1, 2, 3 as the item. So I can call K1 and return that list, 1, 2, 3. And now that I have this list, I can actually then do normal indexing. That's off the list, not the key. So let's go ahead and grab 2, which is going to be at index 1. And this is basically the same thing as separating out into 2 steps. So you could do something like my list is equal to that item at key 1. And then if you look at my list, that was the list before. And you use bracket notation to grab whatever you want off of that list. Or you just do it all in one step along the same line. And you'll have something similar to this in your exercises where we'll have kind of a nested dictionary and nested list. Let me go ahead and show you one more example where you can have actually a dictionary nested inside of another dictionary. So I can say K1, colon, pass in another dictionary with a set of curly brackets there, pass in something like inner key, colon, and then a list of values, 1, 2, 3. So let's say I want to grab this number 2. Well, first thing you have to do is call K1, and that returns this dictionary. Then I need to call inner key off of that, so I can do that with another set of brackets, or I could split it up into multiple steps by using variable assignment, but we'll do it all in one line. And now I have 1, 2, 3, and 2 is at the second index, so that's 0, 1, and that grabs the number 2 there. So again, dictionaries do not retain any order, they are just key-value pair mappings. Now let's talk about booleans. Booleans in Python are quite simple. It's just true and then false with capitalized T and capitalized F. Okay, we'll go ahead and touch back on these when we talk about comparison operators. But let's talk about tuples and then sets. Remember that a list is just defined as a sequence of characters inside of square brackets separated by commas. And you can go ahead and grab items off of that list using indexing. A tuple is very similar, except instead of square brackets, you use parentheses. And you can again just grab items off of that tuple as if it were a list using index bracket notation. Here's the key difference between a tuple with these parentheses versus a list with these square brackets. If I go back to my list and try to reassign the first item to be the word new, whoops. Well, let me run this again because I accidentally reassigned the whole list. Let's check list again. All right, so if I print out my list, I have 1, 2, 3. Let me grab the first item in that list, 0. Perfect. Now let me reassign 0 to be new, just like we did in the previous lecture. And now if I check out my list, I reassign the element at 0 to be new, and then 2, 3. If I want to do that with a tuple, however, if we look at my tuple, it's 1, 2, 3. Let's say I grab 0 and set it equal to new. I'm going to get an error. And this is because tuples are immutable and they do not support item assignment, meaning you can't mutate the items inside of a tuple. Which means you're going to want to use a tuple when you want to make sure a user can't change the items inside of this sequence of objects. And that's the main difference between a tuple and a list. A tuple is immutable and a list is mutable, meaning you can change the items inside of a list. You can't do that same thing with a tuple. All right, now let's discuss sets in Python. A set is a collection of unique elements. And it looks the same with curly brackets as a dictionary, except it doesn't have the colons, it's just elements. Now notice what happens if I type some of these numbers more than once. I still get the same output, because a set is defined by only unique elements. Meaning, if I try to put in multiples of the same element, it will reduce them down to the unique elements. And you can actually call set function and pass in a list to grab the unique elements for you. So if I pass in a bunch of repeated elements into the set function, it returns a set of the unique elements. If you want to add items to a set, you can go ahead and just say, for instance, S1, 2, 3. You'll say S, you'll use the add method on it, put in the item you want to add, for instance 5, and if we check out that set again, we get 1, 2, 3, 5. If I try to add 5 again, it won't retrieve an error, but it will just keep it the same because it's only one unique instance of 5 is allowed inside of a set. All right, we really won't work with sets at all really in this course, but I do want you to be aware of them. They are just a collection of unique elements. Okay, now let's talk about comparison operators. Comparison operators allow you to compare two elements to each other. These are things such as greater than, less than, equals to, etc. For instance, let's go ahead and make a new cell. I can say, is 1 greater than 2? And it will return a Boolean value, either true or false, depending on what your statement is. So 1 greater than 2 is false. 1 less than 2 is true. And you can do the same thing for greater than or equal to, or less than or equal to. You can also check for equality using two equal signs. And notice how the syntax highlighting kind of helps you out here. So is 1 equal to 1? That is true. Is 1 equal to 2? That is false, not true. Now remember, you want to use two equal signs. If you try to do something like this, 1 equals 1, you'll get an error because Python thinks you're trying to do a variable assignment, not an actual comparison operation. If you want to check for inequality, you do exclamation mark equal sign. So 1 is not equal to 3. Well, that's actually true. It's true that 1 is not equal to 3. And you can do the same thing not just with numbers, but with strings as well. So is high equal to by? That's false. It's not the same. Is it not equal to it? Well, that's true. Now let's talk about combining these comparison operators with some logic operators, such as and then or. Right now, we're just looking at one condition. Is 1 less than 2? Well, that's true. What if we wanted to combine it with another condition, such as 2 less than 3? We can use the keyword and in order to do that. So we'll say is 1 less than 2 and is 2 less than 3. And this will return true. However, if one of these is switched to be false, is 1 less than 2? Well, that's true. And is 2 greater than 3? Well, that's false. So we have a true and false will return false. So if the and operator, all conditions must be true. And I personally like to wrap these statements in parentheses so they're a little more readable. You don't have to do it, but I do recommend that you do because it's a little more readable when you come back to this code later on. You also have the or operator, which is really similar, except now in this case, only one of them has to be true. So we can say is 1 less than 2 or is 2 greater than 3. Well, one of these is true. The first one is, so then we get true back. And you can actually stack these on top of each other. So you can say another or here for is 1 equals 1, etc. And if you want to really understand these, you can actually just pass in straight Boolean values. So true and true, that returns true. true and false returns false. True or false is true. And then that's basically it. So it's just or and. Now let's go ahead and discuss some code blocks by talking about if, elif, and else statements. A lot of times you'll want to execute code if a condition is true. And you can use the if, elif, and else statements in order to do that. Let's say we have a condition. If 1 is less than 2, we want to perform some sort of action, like a print statement. We'll go ahead and say yep. So we're saying if this condition is true, colon, and notice there's a block of white space here, and that's really important in Python. Python doesn't use brackets in order to separate block of code execution statements. It uses white space instead. And if you just type enter here after a colon, it will automatically do that indentation for you in Jupyter. And most IDEs that support Python will also do the same thing. Okay, so we have if 1 is less than 2, perform some action. And basically that's just saying this. If true, print, perform code, etc. Or you can just do items like you can say 2 plus 2, x is equal to 2 plus 2, etc. And then when you see x, you'll notice that it's 4. So that's just an if statement. So if some condition is true, colon, execute the block of code that's indented below it. All right, now let's talk about some other operations we can do. Let's say we want to check for multiple conditions. Or let's say we want to have something occur in case it's not true. So we'll say if 1 is equal to 2, print first. Else, colon, print last. And what this is going to do is going to say if this condition is true, execute this code. Otherwise, or else, if nothing above happens to be true, and note how the else lines up with the if statement, that way you know they're linked to each other, colon, print last. So if I run this code, last ends up being executed. If I go ahead and switch this so that the first condition is true, first ends up being executed. Now maybe you want to check on multiple conditions, not just one condition and then some else statement. That is where you can use the elif to check for multiple conditions. So you can go ahead and say something like elif 3 is equal to 3, and let's go ahead and change the first one to be false again. We'll print something else. We'll print middle. All right, so let's go ahead and run this and break down what's happening. Python is just doing this. It's saying if this condition is true, execute this block of code. Otherwise, or else, if this condition is true, execute this block of code. Else, if none of the conditions above me are true, execute this block of code. And you can keep stacking as many elif statements as you want. So you can say another one here. Elif, we'll go ahead and say if 4 is equal to 4, print second. All right, and notice what happens here. Even though this is true, 3 is equal to 3, we're going to only execute the first instance of a condition being true. And that's something important to keep in mind when you're using if, elif, and else statements. It's going to execute the first true condition, and that's it. All right, that's it for this part 2 lecture series. Coming up next, we'll begin to discuss for loops, while loops, and then some other functions in Python. Okay, as a quick review of what we did, we went over, we go back to the top, dictionaries, which again are just key value pairs, and you can grab the values by inputting the keys. And remember, you can have nested dictionaries or nested lists inside of a dictionary. Then we have Boolean values, true and false. We have lists, tuples, which are immutable, very similar to lists, except that you can't go ahead and change stuff once it's inside of a tuple, because a tuple doesn't support item reassignment. We have sets, and remember sets are just a collection of unique elements. So if you have a bunch of repeated elements and you have a set, it's just the unique ones. Then we have comparison operators, greater than, less than, greater than or equal to, less than or equal to, equality check, and then check for inequality. And you can do the same thing for strings. You have these logical operators, and then or, and you can compare multiple conditional statements. And then you have the if, elif, and else logic, which allows you to kind of stack and perform blocks of code based off of some sort of condition being true or not. All right. Hope you enjoyed this lecture. I will see you at the next one.